Alright, so here we are with the 8-5 notes. We're talking about laws of sines and cosines. So this is when we are going to use the law of sines and cosines to actually not solve. Notice that it doesn't say right triangles. Alright, and that is on purpose because we're not actually doing right triangles anymore, as you can see here. So, the formula for the law of sines is a bunch of proportions. So for any triangle ABC, as you can see over here, with side lengths A across from angle A, right? Side length B across from angle B, and side length C across from angle C, we can set up a proportion of the angle as it's taken sine of it over its opposite leg, sine of B over B, and sine of C over C as a proportion that's congruent. So, it turns out we actually get this from things we've done before. So you can use the law of sines to solve a triangle if you are given two angle measures and any side length. So technically angle side angle or angle angle side. And so that'll be an example 1. And then two side lengths and a non-included measure, which would be your side angle. Which of course is technically HL, but not here. Alright, so here's example 1 again, where we're going to be looking at angle side angle. So notice, or actually angle side, we've got the non-included side for 18 here. So what we can do is we look for an angle and an opposite side, because then we can set them up in a proportion. So because we have the opposite side and angle, we can set up our function here, or our equation of sine of, and it doesn't necessarily matter that it was angle A or not, but sine of its angle and its opposite side. So sine of 105 and its opposite side of 18. And then we can set that equal to, well, we don't know what f is, but we could set it equal to sine of f. Sorry, not f, we wanted e, which we do have. Sine of e, which is 32, and then its side length, which would be over here, we just don't know what it is. They do want us to find df, and df is technically e in this point, if we think about it as its side is across from its angle. So, in order to solve this, probably the easiest way to do it is to just identify that these are in fact numbers. So if we take the sine of 105 in degree mode and sine of 32 in degree mode, we end up with sine of 105 as 0.9659, still over 18, and that's going to equal sine of 32, which is 0.5299 over e. And so if we want to solve, we're technically cross-multiplying, so we cross-multiply 18 and 0.5299, and then we divide that value by 0.9659. So our e, again, is going to equal 18 times 0.5299 divided by 0.9659. So let's see, 18 times divided by, okay, so our e value is 9.8750, which of course, does it say to round? Nope, which again is also known as df in this. Alright, so then we move on to example 2, which again earlier we were saying is going to be more of a side-side angle idea. So we do have an angle, we have its opposite side, and then this time we have a side and not its opposite angle, which is of course what they want you to solve for. So to set this up, we're going to do again sine of 75 over 7, and set that equal to sine of s, the angle, over 5. Just like the previous one, it's nice to know what sine of 75 actually is. So sine of 75 is 0.9659. That's still over 7, and set equal to sine of s over 5. To solve, we cross multiply the two values, so we're going to multiply this and then divide by our last digit. So in that case, 0.9659 times 5 divided by 7 actually equals sine of s. So our value is 0.6899, but we're not quite done because we wanted s and we have sine of s. So that means that I need to take the sine inverse of both sides. So if I take sine inverse of this digit and sine inverse of sine, we're left with an s, angle s, equal to sine inverse, so second sine of that decimal, so 43.63 degrees. All right. Next up, we've got the law of law of cosines, that's what this should say. All right, and the law of cosines is a little bit more involved than the law of sines. It's no proportions anymore. It's now this very long algebraic statement, but hopefully you realize that it very much looks like the Pythagorean theorem, right? C squared equals a squared plus b squared. We just have to tack on this extra bit over here because of the fact that it's not a right triangle. So, as before, the reason that we can use this is when we have two side lengths in the included angle measure, which means that we have side angle side. So that'll be in example 3. And then if we have three side lengths. So of course the problem with these is that if we don't have an angle directly across from a side, we can't use sine, law of sines. So we have to switch to cosines. So here's our law of cosine. Again, we're trying to find this side length over here, BC. And in order to get that, we're going to end up having to use the fact that we have A. Well, we don't have A, but that's what we're trying to find. We have B, we have C, and we have angle A. So looking at our formulas, that means we're going to use this one, right? We have B, a C, and an A, and we're trying to find the side length A. All right. So, in order to do that, our formula is a squared equals b squared plus c squared minus 2 times a times b times cosine of a. And by a and b, I mean b and c. Okay. So filling that in, again, we don't know what a is, so a squared is going to stay that way. But b is 9, c is 14, and then we'll take away 2 times b, which is 9, times c, which is 14, times cosine of 62. Alright, so that means that if I simplify this, I can do 9 squared, which is 81, 14 squared, which is 196, I'll double check that. Yep, and then we're going to do minus 2 times 9 times 14 times cosine in degree mode of 62. So minus 118.3068. And all of that equals a squared. So, if we simplify that, 81 plus 196 minus 118 leaves us with an a squared of 158.6932. So to solve, we take the square root, and now we finally know the side length of a as 12.60 if we round. And again, that's the length of BC. Alright, so kind of a lot, but of course we take it in term sections. So we've got this piece, then this piece, then this piece, which again is big, but it's still just one multiplication row. Alright, so then we move on to our last example. Again, this one was the side, side, side. So notice that they want you to find the measure of angle R, And so we just need to know that then if that's the measure we're trying to find, then 9 needs to be the piece that's out here. So if I call this one A, angle A, and this one side A, then this could be C and this could be B, and we could use the same formula we had. So A squared equals B squared plus C squared minus 2BC times cosine of A. Because of course they're labeled R, S, and T, so we get to put in our own formulas there. So filling it in, we know A this time, so that's 9 squared. B is 4, so that's 4 squared. C is 7. Then 2 and B is 4 and C is 7. And then cosine of A, which we don't know. So what I'm going to do this time is figure out these pieces, and then we'll talk about solving. So 9 squared is 81, 4 squared is 16, 7 squared is 49, and then 2 times 4 times 7 is a negative 56 times cosine of A. So basically what we're going to do is isolate this piece here because it has our variable that we're trying to solve for. And so I'll subtract this 16 over. So 65. And then I'll subtract out the 49. And then our last piece, notice that we have multiplication going on. So that means that I'm going to divide by 56, negative 56, to both sides, instead of what you might think of adding instead. So 16 divided by negative 56 is negative 0.2857, and that's going to equal cosine of A. And so just as we did before with sine and we were solving, we need to take the sine inverse, or in this case the cosine inverse, in order to get A by itself. So I'm going to take cosine inverse of this negative digit and cosine inverse of cosine, which will leave me with A, and cosine inverse of that decimal gives us 106.60 degrees. Solving the law of cosines backwards is just a little bit harder than your law of sines, but the idea is still the same, and especially if you use this idea of grouping it into pieces that you can find, then you just end up subtracting out the two individual numbers, dividing by the piece in front of the cosine, and then of course taking inverse. So you're going to have some problems that will tell you to use law of cosines or law of sines, and you're going to apply these formulas.